In this video, we're going to take a look at a question from the Morin Mechanics book, Classical Mechanics. And this is a pretty simple question. It's question 1. And this is the sort of question that comes up in a lot of different exams from time to time. So it's basically about a hanging mass. And there is supposed to be a figure, but it's pretty easy to draw. So we'll just draw it ourselves rather than taking the image from the book. We're given a mass M, and it's held up by two strings, which are hanging on the ceiling. So let's say this is the ceiling. And then the strings are like this. And then they form a right angle. So that right angle would look like this. Okay. In terms of the angle theta, now actually I kind of forgot, but I think this was the theta. I'm pretty sure that's how it was. So this would be 90 degrees minus theta. And then right over here we've got the block of mass M. Right, and so based on this, we want to see the tension in each of the strings. So we can call the tension here tension 1, T1, and this is T2, and we want to find both of them. So the first thing that we know is that it's hanging from a ceiling. It's not falling down, it's not going up. So the vertical motion is 0. There's no vertical acceleration. And from that, we can say that the net force in the vertical direction is going to be 0. Right? So force Y and the net is 0, which means that, well, what's the force downwards? That's going to be mg, right? And then we have, well, okay, I mean, there are a few different ways of doing it. We can just say that the force downwards, mg, is going to be equal to T1 times, so tension 1 times the sine of 90 minus theta, which is tension 1 cosine of theta. And then over here, we're going to have tension 2 sine of theta. So it would be like this. Sorry, sine theta. So this is one of the equations that we have, right? Now there should be one more, of course, and that's going to come with the horizontal motion. So we know that the force in the x direction, the net force here, is also equal to 0, which means now we have to be a little careful with the signs, but essentially this force and this force, these components of tension 1 and tension 2, should end up cancelling up. So we would just have T2 cosine theta, sorry, is equal to T1 sine theta. Okay, not too bad. Now, let's see. We're given this information, we want to probably just solve for it and see what comes up. So we can just isolate T2 over here. That will be T1 times tan of theta. So we can now plop this in here. And what do we get in doing that? We get, so this is what we're doing. We're going to plug this in here in the first equation. And so we get mg is equal to T1 cosine theta plus, be a little careful with this, it would end up being, I think, T1 sine squared theta over cosine of theta. Now at this point, it's not too difficult. It's, out of space here. Okay, so what you would do here is essentially multiply both sides by cosine of theta to get mg cosine theta equals tension 1 times cosine squared theta plus sine squared theta. That's of course just 1. And so we get tension 1 is equal to mg cosine theta. Now that we found this, we know that tension 2 is just this times tan of theta. So that would be sine theta over cosine theta. So tension 2 would be mg sine theta. You could have done it the other way. You could have instead solved for tension 2 first. And of course, you'd get the exact same answers. But yeah, these are the final answers. And just like that, we've solved this question. It's question 1. And so it's not meant to be like very, very challenging. It's meant to just be like a kind of basic application. But yeah, as you can see, there is a little bit of math involved over here. You have to make some substitutions and solve it. But at the end of the day, it's just pretty basic ideas of balancing forces in the two directions. So that's it for this video. Hopefully you enjoyed. Hopefully you learned something new. If you did, please make sure to subscribe so that you can stay tuned for more videos like this, whether in physics or in math. And I'd of course really appreciate it as well. Thank you so much, and I'll see you in the next one. Bye bye.